3. Pretty cool lesson. I think sadly we're not really going to get to do this in class, but I want to talk about it quickly anyway. So what would happen is we would talk about, first of all, like this shape, which I think is a really cool shape. I don't know if you guys have ever seen this before. Probably most of you guys have. But there's no curves on this picture at all. And I don't know if I can really zoom in closely and do this justice or not. But the idea being that when we look at this, there's no curves at all. This is all straight lines. It just, from this fixed point, it goes from this fixed point to each of these points, and then it just sort of goes along. And the more of these that you put in, it makes it look like a curve. So that definitely looks like a curve, but it's not. So it's really in line with what we talked about with the circle back in chapter 8, where if you make a circle, if you make like a polygon infinite sides, it's essentially just becomes a circle. Same thing. The more you chop this up, the more it looks curved, but it is actually straight line, straight line, straight line, straight line. So I think that's kind of neat. Then from there, we would have gone on to discuss what we were doing for the day, which is the focus and the directrix. And honestly, nothing to do with integrated 2 at all. This is just a setup for integrated 3, but some really cool stuff that you're going to learn about in integrated 3 that has to do with like satellite dishes and barbecues and the focus and how that works. It's pretty cool. However, I would have given you this funky graph paper, focus directrix graph paper, and we would have just done a little bit of stuff in this lesson. And what we would have come to find out is essentially this, that the directrix is a line that once you pick this point, it's equidistance from the directrix as it is from point F. So anywhere on this parabola is going to have the same distance to the directrix, obviously at a perpendicular angle, as it does to point F, which is kind of interesting. I mean, I'm not sure if some of these look closer, like maybe this looks like it would be closer to point F than it is to the directrix, but that is not the case. That this directrix, if drawn correctly, will always have the same distance between the two, which is kind of interesting. And that's pretty much it for the lesson for the day. And quite frankly, we do this in class, and then I don't assign homework. So I hope you enjoy your assignment of no work.